All right, today we're going to look at sample size calculations for desired margins of error. So this goes along with confidence intervals. We talked about confidence intervals for means. We talked about confidence intervals for proportions. So I want you to recall the formula for the confidence interval for a mean, right? And when we're talking about these margins of error and sample size calculations, we're only going to deal with the situation where we know the sigma, the population standard deviation. We won't concern ourselves with trying to find desired sample sizes when sigma is unknown. Where there were two cases for the confidence interval for the mean. If we knew sigma, we used this and z critical values. If we did not know sigma, we had to substitute the sample standard deviation and use the t critical values. For these calculations, or sample size calculations, we're just going to concern ourselves with the known sigma situations. So recall the formula for the confidence interval for a mean, right? The sample mean was the center of the distribution, and this is the margin of error, right? We went out on both directions, plus or minus this much on either side of that center point of the interval, and we call that the margin of error. So all we're doing is looking at that margin of error. I'm going to call it E, okay, for margin of error. And that's what we're looking at here is this right here, right? This is this. And all we're doing here is now we're going to solve this equation for n, right? So if we solve this equation for n, or if we multiply both sides by the square root of n to get to this point, and then divide both sides by e to get to this point, and then square both sides to solve for n, right? We're just solving an equation for one variable in terms of others. And we end up with this formula. This is the formula to find the desired sample size, or sorry, to find the minimal sample size for a desired margin of error. So if you want a margin of error to be a certain amount or not more than a certain amount, we need a certain amount of individuals in our sample. And this is the formula that we use. So looking at an example of that, let's say we want to find the minimal sample size required so that a 95% confidence interval will have a margin of error of 0.4. Right? Well, all you got to do is solve that expression here. 95% confidence tells you what the z critical is. Right? Hopefully we're starting to be familiar with these z criticals. If not, look up the z critical. For 95% confidence, you'll see it's 1.96. And in this case, we need to be given the population standard deviation. Okay, so we're given that the population standard deviation is 3. All right. So we have sigma, we have the z critical, and we have the desired margin of error. So we have everything we need. We have z critical, we have sigma, and we have the desired margin of error. So we just plug that into the formula, z critical, sigma, desired margin of error, find that ratio, square it, and always round up to the next whole number for these calculations. Always round up to the next whole number. Because if you need 216 and a half, 216 isn't going to do it. 217 is what you're going to need to satisfy the conditions of the problem. So we need 217 people in our sample to form a 95% confidence interval with a margin of error of 0.4. Now notice, if you increase the confidence, what's going to happen? If we use the same data, the same population standard deviation, and the same desired margin of error, the only thing that changes from 95% confidence to 99% confidence is the z critical value. Right now, the z critical value is 2.575 or 2.58, depending on which table you're looking at. But that's the z critical, sigma, desired margin of error. Notice now we're going to need more. Right? We're going to need more individuals in our sample for 99% than we did for 95%. That's always going to be the case. The more confidence you need to have, the more people in the sample, not people, individuals, people, places, or things that you're going to need in your sample. So for means, this is the formula. For sample size, minimal sample size for desired margin of error. And this is the example for that. Increase confidence, you're going to need more in your sample. And we also want to do this for proportions. Okay, so if we do this for proportions, we're going to see same idea. Recall the formula for the confidence interval for a proportion. So this was now the margin of error. This part here, call that E. Same exact idea. We're going to solve this equation for n. Okay, so we go here, separate these, so hopefully you can see them clearly. So we're starting here, and then first thing I did here was divide both sides by the z critical value. Again, we're just trying to isolate the end, right? So I divide both sides by the z critical value to get to this step. I square both sides to get rid of the square root sign. So I square the left-hand side, I square the right-hand side. And then I multiply both sides by n, just to bring it out of the denominator. So multiply this side by n, multiply this side by n. And now all I have to do is divide through by this entire term. So if I divide, remember a fraction, if I divide, this is e squared over z critical squared, if you remember your algebra exponent rules, right? So if I flip that, I'm going to get z critical squared over e squared. So dividing both sides by this term, I'm left with what I want here on the left-hand side. And I get this on the right-hand side. And here's my formula. So this is the formula for the minimal sample size required for a desired margin of error when we're talking about proportions. Now, here we got to be a little careful. This is very important. If we have an estimate for the population proportion, a p hat, if we have an estimate for that, we're going to use it in this formula. Okay? But if we're not given an estimate for the population proportion, then we're going to use 1/2. Okay, so some problems with concerning this question, you'll be given a p hat to use in the formula. If you're not, don't let that bother you. If you're not given a p hat, use 1/2. It's kind of the safest number to use. It gives us the largest sample size when we don't know what the p hat is. So it eliminates any sort of bias or error. Okay, so p hat, if given, you're going to use it. If not, you're going to use 1/2. So here's an example. Again, let's say we're given a p hat of 0.8, and we want to find the minimal sample size for a 99% confidence interval. And here, just because I ran out of room here a little bit, I'm using 2.58 instead of the 2.575 that I used over here. Close enough. 2.58 for my z critical for 99%. We're using the p hat given to us, 0.8, 0.8. 1 minus 0.8 gives us 0.2. Z critical over the desired margin of error squared. We calculate that value, round up to the next highest whole number, and we get 296. So we need to have 296 individuals in our sample in order to form a 99% confidence interval with a desired margin of error of 0.06. So now notice, if we don't know p hat, we have to use 1/2, 0.5, and 1 minus 0.5 is 0.5 again. So 0.5 times 0.5, that's the only thing that changes. And notice this number is always going to be more than any other p hat, and that's why we use it. Okay, because 0.5 times 0.5 is the largest number we can get when we multiply two numbers that are less than 1. And 1 minus that number. right? So notice 0.8 times 0.2 gives us 0.16. 0.5 times 0.5 gives us 0.25, a much larger value. And that's going to lead to a larger sample size, right? So if we don't know what p hat is, we need to include more individuals in the sample to achieve our 99% confidence interval with a maximum error of 0.06. If we have the information of an estimate for p hat, we need less individuals in the sample. If we're missing that information, we need more individuals in the sample to satisfy the conditions. All right, so minimal sample sizes needed for desired margins of error. This is something you want to understand and use. This is the formula for means. This is the formula for proportions. Proportions, you have two cases. If you know p hat, you use it in the formula. If you don't know p hat, you use 0.5 in the formula. All right, so pretty short video there. See you next time.